Good afternoon, everybody. Welcome. My name is Mike McGee. I'm a senior technical marketing engineer with Nutanix.
And my name is Chris Brown. I'm a solutions marketing manager for Nutanix.
Yeah, so really excited to be here. For those of you listening online at this recording, you wouldn't believe the packed house, standing room only. The reality is Thursday. It's a relatively small crowd. Actually, pretty good turnout though for this time of the conference. So really appreciate you coming along. If you do have questions, feel free to just throw them out. We can repeat them you can use the microphone or not. We'll repeat them for the folks online. But given the size, we can keep this interactive and try to keep it fun. All right, so why are we here? So obviously we're at Ignite. Microsoft has a very strong focus on the cloud, and the cloud is impacting a lot of the business decisions people are making within their IT departments, but also from an infrastructure perspective. A lot of the benefits that you get out of the cloud, things like faster time to market, ease of usability, pay as you grow, constant innovation. If you look at all the changes that have occurred over Azure or other cloud vendors over the years, constantly introducing features using things like microservices, fast deployment, et cetera. You really get the idea. So to get that kind of benefit from the cloud onto your on-prem infrastructure is an important focus. It's one of the things that Nutanix focuses on specifically. So with that, really what we're trying to add for your on-prem infrastructure, so similar to how you take that consumption model from the cloud, we want to be able to add that consumption model to what you do on premises. So really the idea is you take the benefit of the cloud, but actually run it within your enterprise. Some of the key points to that is fractional consumption, so the idea that you're growing an environment at a particular size. In our case, you would be adding individual nodes as you grow or expand an environment, really bringing that pay as you grow, pay as you go, start small and incrementally scale as you need to. It needs to be very simple to consume. It shouldn't be hard or difficult to expand, whether it be migrations considerations or standing up the environment, migrating the environment, whatever it happens to be. It needs to be very simple. As things become simpler as a part of the infrastructure, even as a part of the cloud, what you'll see is a lot of the roles and responsibilities within the enterprise are going to evolve. You won't necessarily have just a storage admin or just a virtualization admin, server administrator, network administrator, et cetera. A lot of these roles are converging and making it much simpler or easier for folks to focus on the higher level applications. If you think about how when things move to the cloud, you're not as worried about networking, you're definitely not worried about storage or virtualization. Really, the virtualization layer in the cloud almost doesn't matter. It becomes a platform as a service, it becomes software as a service. So as IT administrators, as people within the IT department, we really need to elevate that conversation, focus on the application, what you get out of SharePoint, Office 365, Dynamics in the cloud, SQL, et cetera. But the same should apply for your on-prem infrastructure. If you're running things on premises, you need to be able to focus on the application, really less about the underlying infrastructure. The benefit of having some things on-prem, and just by a show of hands, how many people are really looking at a hybrid model when it comes to what they have on premises and what they have in the cloud? The majority of the people here. Some people are focused on 100% cloud, but the reality is you'll have some form of operations on premises as well as into the cloud. So taking the same benefits that you would get out of the cloud and applying it on-prem, but then maintaining that control. So you have control over the security to a certain degree, you have control over performance, so you can define whether you want to do all flash or things of that nature. So really have a lot of control over what you do on premises, but taking the same benefits from the cloud. Chris, anything to add there?
Yeah, one of the other points we have on here is continuous innovation. If you think about it, you log into Azure one morning and you've got new features, you've got new performance, you've got new VM options. And you didn't have to plan a maintenance window, you didn't have to plan for downtime or anything like that. New features just showed up. That's the same idea that we want to bring down to the on-premise infrastructure, is the ability to have those basically those non-disruptive upgrades that you don't even notice happen because you don't need to. But at the same time, we want to make sure you get the control that you desire for your data. We've got balance, renting, and owning on here. But basically the point for that is that the cloud makes a lot of sense for many workloads. But if there's a particular workload you're running 24/7, 365, it might make more sense to own the hardware that runs it on. I mean, you don't rent a hotel room every day of the week. You buy a house if you're living somewhere for a long period of time. And the idea is that we want to be able to give you that control to figure out the ratio that's right for you and your business.
Yeah, and I don't know how many people in the virtualization space are running Hyper-V versus ESX. Anyone running ESX in their data center? Absolutely, and a lot of people are evaluating other hypervisors. Like I said, hypervisors shouldn't be a primary concern, but the reality is there's licensing considerations. There's whether you're comfortable with a given hypervisor, et cetera. So a lot of people are looking at choice and having flexibility, whether it's different clouds, different hypervisors, and options along those lines as well. So having something to help enable that is important also. So we're obviously Nutanix. We're a hyper-converged vendor. We're going to get in more details if you're not familiar with Nutanix. I mean, just by show of hands, has everyone heard of Nutanix, have some background in what we do and how we operate? So about 50-50, some people know and some people don't. But it really starts with hyper-convergence. And what hyper-convergence is, it's a combination of your server infrastructure, but also your storage, and combining it into a single, really easy-to-consume appliance. If you look at the cloud industry, it's very easy, fractional consumption, easy to consume. But if you really look at existing infrastructure, it's very complicated. You tend to have multiple vendors. You tend to have multiple types of things that you're going to utilize. For example, storage area networks. So you have fiber channel switching perhaps, or iSCSI. You're going to have different storage array vendors, et cetera. So what Nutanix does is essentially make it so you can take those tiers or those silos within the data center, so your storage area networks, your SANs, and also your storage arrays, and make it so you really don't need to have that. Essentially what you're creating, some people coin it a server SAN, but really what at the end of the day we call it hyperconvergence. And that's the idea that you're combining the services that you would otherwise get out of a 3-tiered storage architecture, and you're getting out of a simple to consume appliance, something that can grow a node at a time and offer you that fractional consumption that's cloud-like. But really converging the hardware is just a part of the story, right? We want to make it so you can use any virtualization layer that you would want. So whether that's Hyper-V, ESX, AHV, which is Nutanix's hypervisor, really enabling that choice. So if you have operations that want to use a certain kind, you'll be able to do that. But at the end of the day, that virtualization layer should really be invisible. You should really be focusing on the application. So if you're converging the hardware, you should also be converging the operations, otherwise associated with the hypervisor, so you can focus on the VMs as well as the application. Yeah.
I mean, if you think about clouds, I mean, Azure's kind of a bad example because everyone knows that Azure runs on Hyper-V. But how many people know what hypervisor AWS uses? And to be honest, you don't care. The virtualization layer, it should be there to give you the features, but at the end of the day, you don't care what hypervisor it is, as long as it gives you that. And the other key point about Nutanix here is that we do everything in a scale-out fashion. So in order to give you that true cloud experience where you can add a node as you need, fractional consumption, we make sure that each individual node that gets added it gives you performance in a linear fashion. There's not a cliff that you hit or a point where you've got to do a forklift upgrade or where you've got to rip out a bunch of stuff to replace with new stuff. You're able to grow at whatever speed you and your business require, and know that you're going to continue to perform thanks to scale out.
Yeah, and I know we're talking a lot about virtualization, but does anyone have container requirements for microservices development? Maybe not today, but containers are coming as well. So the idea that we're not just needing to focus on virtualization, you can see Linux containers or Linux-based containers being supported with, say, NanoServer with Server 2016. You see they're supporting it within Azure, the other cloud vendors supporting it as well. So you talk about mobility, moving in container, whether it be across hypervisors or across clouds for portability's sake, is actually much easier than, say, moving a virtual machine. A lot of if you haven't been hit with this yet or you have internal teams looking to do that, that's something coming as well. So really, again, raising that conversation above just even the hardware or the VM, but also getting into where developers are touching things at the container level. And so that's really where we're going. So really, hyperconvergence starts with making the infrastructure simple, but you really need to be able to add the services on top of that. So whether that be features within that underlying form of the infrastructure, whether that be adding things like self-service on top of it. I don't know how many people are using the Azure Pack or perhaps interested in the Azure Stack. Show of hands, anyone go to those sessions? I mean, so you're really, when you start looking at that, you're really elevating the conversation, a platform as a service, whether that's running website clouds or database as a service with SQL or MySQL, or even infrastructure as a service where you're deploying virtual machines, and giving end users the ability to do that allocation, to allocate those VMs, assigning quotas. So different departments really have the capability to get that consumption. Because really, that's how you're going to prevent shadow IT. That's how you're going to prevent departments from going into the cloud and throwing in a credit card. Because really, it's that I need something on demand, I need it when I need it, and I need it to be very easy to consume. So really, creating a platform is the key. So whether you're looking at something like Azure Stack, OpenStack, or even we're adding self-service capabilities as well within our platform. And that's really the key, is that you're getting that ease of use and ease of consumption, not just as an IT administrator, but also for your consumers. So to peel back the kimono a little bit and get into more details. So Nutanix was founded by one of the guys that wrote the Google file system, or was a contributor to, one of the main contributors to the Google file system. So you think about the way in which systems are created within Azure or within AWS or Google, et cetera. You're talking about rows and rows and rows of commodity servers, x86, based on some form of hypervisor at the end of the day. When you have failures in these kinds of environments, do you think the second a disk fails that someone jumps in and immediately runs down that row and replaces that disk? Probably not, right? At the end of the day, what happens is you need to be able to fail and reconstruct with what you have. And at the end of the day, in these data centers, what ends up happening is these guys row down the rows in these carts, and they'll replace a failed server, they'll replace a failed drive, et cetera. So really at the heart of what Nutanix did was to take that same mentality but bring it to on-premises infrastructure. So if you lose a node or lose a drive, we'll actually rebuild down to that smaller size, and then when you replace it, we'll rebuild out to that larger size. So it's a true distributed scale-out system based on commodity hardware defined in software. Chris, do you want to get into some details about the architecture?
So if you take a look here, we've got the x86 servers down at the bottom. These can be Supermicro, white box servers, or Dell, Lenovo. We also support Cisco UCS and some specialized things today. On top of that is your choice of hypervisor, so in this case Hyper-V. On top of that runs our controller VM. These controller VMs run one per node, and they talk to each other to pool all of the local disks together into one distributed storage fabric. And so the advantage of that is, as you see in the bottom, this distributed storage fabric gives you all of the features that you've come to expect from your storage array, such as data efficiency with compression, dedupe, and EC, erasure coding, I should say, with things like replication, not backup, but replication, snapshots, and resiliency. So if you lose one piece, you don't lose you don't lose data, and adds in some new ones, such as data locality. We strongly believe in keeping the application as close to the data as possible, which is going to become increasingly more critical as we start adding technologies like NVMe and 3D XPoint. I don't know if you guys have seen how fast 3D XPoint is, but in order to take advantage of that over a network, you're going to need to have 100 gig NICs in your servers, and even then you won't reach the maximum speed. And so the only way to take advantage of these new technologies that are coming out in the next few years is to have the application live as close as possible to the data. But at the same time, you don't want to lose that control and that flexibility that you've come to expect.
Yeah, and we talk about scaling, to very, very large scales. You talk about Azure, AWS. I don't know how many people were here for the keynote, but they were talking about growing in increments of thousands of nodes at a time, right? I mean, pretty incredible. So designing the system for that is one thing, but most of small business enterprise, we're obviously not operating at that scale. So the key is to bring those benefits, but also allow you to do it at a very small scale. So we start as small as 3 nodes, and that can fit within 1 TU appliance. So you can use it just as effectively if you were doing a robo scenario, putting these clusters out in retail sites as you were creating hundreds of nodes or even thousands of nodes within a primary data center. So bringing the benefits really regardless of the scale. Now we talked about flexibility, ease of use, and having choice. So as a part of that, we've developed what we call the Application Mobility Fabric. And with the App Mobility Fabric, what that gives you the ability to do is to move VMs between different hypervisors or replicate to different clouds. Really, at the end of the day, you want that choice, you want that flexibility. Maybe you want to move away from ESX for licensing considerations, whatever it happens to be. But you want to make it as easy as possible to convert what you have, or even replicate to a different hypervisor, if you will, for the purposes of maybe a more cost-effective backup target or even a more cost-effective disaster recovery target. Chris, anything to add there?
No.
Awesome. So making it easier to initially consume, simple to scale, easy to migrate and move things around based on your choice, but also easier to manage. So if you think about traditional environments, going back to that slide where we saw different vendors all within the same data center, whether it's a storage area network, switching, hypervisor, whatever happens to be, you're generally left with multiple interfaces, multiple APIs, multiple GUIs.
Some may be GUIs, some might be command lines, some might be a mix.
Absolutely, and you think about, again, going back to the Azure Stack, what's amazing about the Azure Stack and where Microsoft is going is they want to give you one common set of APIs, whether you're running on-prem or running in the cloud, really to help enable that mobility. And the same should really be true for your on-premises infrastructure around management. So having a very simple way to consume, whether it be REST API-based, PowerShell-based, or GUI-based. So very easy, intuitive, and simple.
Yeah, and as part of this, because the Nutanix software is able to be integrated across the stack, we have insights into everything from the VM level to the host level to the storage level. We're able to offer deep insights for predictive growth analysis and what-if analysis. So we can tell you, because we've got access to everything, how long your storage will last, how long your CPU will last at your current growth rates. And this is something that comes natively built into the product. You don't have to spend tons of time programming it or getting it working just right.
Absolutely. So we call that interface Prism, as well as Prism Central, and it really gives you the ability across the board, whether that's managing virtual machines, getting insight into your environment, health alerts, events, whether that's expanding clusters, shrinking clusters, troubleshooting, et cetera. So it really gives you centralized management. And on top of that, if you think about having multiple clusters within an environment, we want to be able to aggregate that view so that you can get a single pane of glass for all of those different pieces within your data center. So we have something called Prism Central, which allows you to take the management interface from all of these different clusters that you might have and put them into one logical view, really centralizing those operations.
So now that we've gotten the main overview of Nutanix, let's get into the meat of the thing here. First off is how does Nutanix and Hyper-V work together? We talked a little bit in general about how what Nutanix does and how we approach things and what our vision is. But let's talk about the tech. So the first piece here is that in this diagram we're kind of showing how the Nutanix cluster and the Hyper-V clusters work together. If you look at the top, we've got 4 CVMs which match up to the bottom 4 hosts. On the host side, we've got a Windows failover cluster, which provides the live migration and the high availability that Hyper-V, the expect from Hyper-V. On the Nutanix side, we've got an external IP, and then we've also got an SMB server, an SMIS provider, and a VSS agent. So from the Nutanix perspective, we integrate with Hyper-V in a few ways. The first is obviously that we're running on the hosts. The next is that we've got an SMIS provider to automatically update SCVMM about what the storage looks like and what's going on. And then finally, we provide SMB storage for everybody. And so we are able to do things like provide I believe the VSS agent's coming, right?
Well, so there's a few forms of VSS. You can look at, if you're using SMB, there's actually VSS for SMB shares. Anyone doing, that kind of backup today? So what VSS for SMB shares allows you to do is actually take a backup, if you will, of that entire SMB share. So there's obviously VSS on a VM by VM basis, and then there's a more global form of VSS where you quest the virtual machines, but then actually take the entire SMB 3.0 container, if you will, as a backup target. You then redirect to that, mount it to a proxy host, and then you can back up the VMs from there. And in our case, it's actually based on a snapshot. So it gives you backup offloading and the ability to really capture a group of VMs all at the same time. The alternative to that is a VM by VM VSS-based snapshot. And we have something called Nutanix Guest Tools, which, to your point, we're porting over to Hyper-V in the very near future. But one of the real cool things about how we do the architecture is because we do it based on virtual machines, all of our CVMs is where our intelligence runs. And that's the unit at which we can actually do upgrades. So whether you want to do an upgrade of the hypervisor, upgrade of our storage stack, upgrade of the firmware, we help to automate that process really across the board and allow you to do it independently. So to upgrade your storage stack to get the benefit of some of these improvements, like, for example, VSS within the virtual machines themselves, you don't have to upgrade the hypervisor necessarily. So again, it gives you that flexibility. Want to talk about the networking?
Yeah. So in order to make Nutanix give you that distributed file system with the locality, we've got to do a little fun stuff with the networking. With Hyper-V, what we do is we create two switches by default, an external switch and an internal switch. On each one of the hosts, the internal switch has the exact same configuration. There's no NIC uploads from the internal switch. There's just the CVM and the host. And each host and each CVM has the same IP on the internal switch. The external switch, however, is how the Hyper-V host, or whatever hypervisor you're using, connects to the upstream network. This has your NIC teams. By default, we use a switch-independent dynamic load balancing mechanism. Excuse me. And then the CVM is also connected to this external switch. From there, the CVMs are able to talk to each other to pool their resources together. So this means that anytime that the host is trying to read or write something, because it's got a VM doing that, the communication happens over SMB over the internal switch. If the CVM needs to go to another CVM to get that data, because it's in another location in the cluster, the CVM will translate it and send it out over the external network to the other CVM directly, using our protocols, not using SMB. So all of the SMB communication happens internal to the server.
Absolutely, and if you think about one of the core computer science principles of locality, right? I mean, how many people are familiar with NUMA, non-uniform memory access? It's one of the things that you have within a hypervisor to kind of give awareness of where the memory is literally connected to the CPU. You get much better performance, say, with SQL and databases if you're NUMA aware. But the principle is you want to keep the processing as close to the memory as you possibly can, and we're applying that same principle. Again, our founder is just this brilliant guy from Google, and the guy was a savant, and he wanted to bring that same idea, but to the storage itself. So if you distribute the data across the cluster for high availability and rebuild, et cetera, but if we have full metadata awareness of where that data lives, so if we can choose to retrieve that data locally as opposed to going over the network to retrieve it from a different node, that's what we're going to do. So on top of that, to be able to do that efficiently, we created this internal network, if you will, through which we do that SMB communication. So not only are we reducing anything we have to go across the physical network to do, we're actually keeping it within that node as well. And you think about SSD and NVMe and 3D XPoint going forward, there's more IOPS and throughput that you can get out of one of these nodes than you're likely ever going to use by an individual VM or application. So using data locality increases performance, reduces the need to have specialized networks like RDMA, et cetera. No reason why you couldn't use them, but the reality is it becomes less dependent on having to have an InfiniBand backend, 40 gig backend, et cetera, because you're reducing the amount of traffic that really needs to go across the network.
So here we just have an example of how data locality works and how a write happens. So here we've got, as you can see, we got node A. He's got a guest VM with 3 bits of data on it. So when he does the write, we send one copy to the local storage, and then we replicate the other copies across. So during this, yes, we hit the network, but resiliency is more important than just raw performance here. So once the write is done, we return to the OS. So at this point, we have 2 copies of the data, and we can lose one without a problem. Yes. So basically, when you do a write, we will write it once locally, write it once remotely. When both are done, then we return that the write was complete. So it's all synchronous. And that way, if the node dies, you don't have corrupt data.
Yeah, and to that point, it's to SSD. So it's not in memory. We don't have to be battery backed or anything like that. So It's going to go to persistent, non-volatile memory.
Yep. So then from there, at that point, if we're doing reads, we've got a local copy. But what if we read a copy remotely? So the guest VM is here reading data locally. Everything's happy. Let's say we do a live migration. So right now, we got the VM on node A here, and it's accessing all the local data. If we do a live migration, we move it over to node C. Now we're reading some of the data remotely, so that's not great. So node C will recognize that it is the new host for that disk, for that VM, I should say, and we'll move that data back local so that you get the performance again. So obviously, the first read is going to be over the network, and that's not perfect, but future reads will be from that local SSD again.
Yeah.
So basically, since every host has a CVM, each host talks to its local CVM to get the storage. So when the VM live migrates to another host, now a different CVM is getting requests for the storage rather than the original one. So now that CVM knows that VM has been moved. No, we don't. We actually base all of our intelligence just based on the read-write profile that we're getting from the different controller VMs. So you don't have to you don't have to set up something so the Hyper-V cluster tells Nutanix. We'll figure it out on the back end.
Yeah. So I mean, so the key to the question around, just so anyone listening online. So the question is really around: is there any additional logic happening at a different layer to say, hey, move the data, or within the cluster? And the reality is, what we'll do is only if the VM requests the data from another node will we even attempt to pull it over. And even then, it would have to be multiple reads by default. So we don't want to just arbitrarily move data around within the cluster without there being a net benefit. So if there's a remote read operation, I think it's a couple within a certain time frame, we'll go ahead and relocalize data to that particular node. But the important thing to understand is we don't do it arbitrarily. We won't just start pulling the data over just because it could be cold. You might not be reading from it. There's no need for us to relocalize it, based on the movement. But the key differentiation here, especially with other, maybe other products in this space, is that we're fully distributing everything across any node, and any VM can move to any node within the cluster. And then you'll get the benefits of locality over time as we relocalize, or if not, if we don't have a reason to move the data, we won't. So with that, and as we've really have expanded our support, we've when we first started, a lot of people weren't familiar with hyperconvergence. They weren't familiar with this kind of deployment. And this kind of mode, if you will, for deploying applications. So you can imagine, people started with test dev to a certain degree. Maybe they looked at VDI, a scale-out platform, node-based platform, where you could have maybe 10, 20, 30, even 100 virtual machines per node. Made sense for this kind of scale-out architecture. But we've since seen that the majority of our workloads at this point in time have really evolved to include anything, whether it be Splunk or Hadoop, enterprise applications like we have with Microsoft. The enterprise cloud workloads, et cetera, and we'll get into a subset of these. But really, this kind of architecture fits across applications. It's not a certain niche.
Yeah. So in this box, basically, there's it's a server. You install Windows and you put Hyper-V on there. On top of Hyper-V, so the question was for those of you what does this box actually look like? Is Windows actually installed on this box? Yes. So you got Hyper-V installed. On top of that is just our VM running. The VM gets the disks passed through directly to the VM, and then it presents the storage pool back to the host as a SMB share. So each one of the hosts is running Windows or ESX or whatever hypervisor you choose. So we sell in an appliance model. All of the intelligence is in software, but we sell it in an appliance as basically a super strict HCL to ensure the level of experience. But we have a tool called Foundation. So when the block comes from the factory, it will have the KVM hypervisor on there. But using Foundation, it can discover the unconfigured nodes and then automatically install Hyper-V along with our software on top of it.
Yeah, so imagine getting shipped, let's say 8 of these blocks. So we have the concept of a block. Within a block, you could have 4 nodes, 2 nodes, or even just 1 node. So that foundation process, for example, you could have 8 blocks, 32 nodes. You basically rack them up to a top-of-rack switch. You discover it with this foundation applet, and for all those nodes in parallel, we'll either install ESXi, install Hyper-V on a local SATA DOM. So there's a SATA DOM within these nodes that you would install the operating system, and then we would set up that networking configuration that you saw. We'd enable our CVM, And really, by the time it was done, literally within an hour or two, for a cluster that size, it'd take a few hours. But for a smaller cluster, 3 nodes, it could be up in as little as 45 minutes, 30 to 45 minutes. And you're ready to start allocating storage and creating VMs at that point. Does that help? So let's talk about private and hybrid cloud. So, obviously with Microsoft and Azure, there's both an Azure solution, but also an on-prem solution. And Microsoft started a few years ago with something called the Azure Pack. Is everyone familiar with the Azure Pack? Heard of it before? Couple of hands. Yeah, so the Azure Pack was really the first revision, if you will, to give an Azure-like experience, but for on-premises. What was great about the Azure Pack is it had the same look and feel as Azure at the time, really the V1 API and the first version of the external interface. So you had the opportunity to do infrastructure as a service with what was known as VM clouds. You also had the ability to do IaaS as a service, which fell under website clouds. You could install SQL and allow that to be kind of self-served, if you will, to your developers, but really giving you an Azure consistent interface. What the Azure Pack didn't have, however, was a common set of APIs, and really the underlying software, if you will, that supported the Azure Pack, being System Center, was somewhat different than what you were actually doing within Azure. So you're relying on something like System Center or Virtual Machine Manager to create those VMs for you through the Azure Pack. And that's really where the Azure Stack was born, where the Azure Stack is literally the same software that you would otherwise get out of Azure, actually running on premises. But the Azure Pack still is a great solution. It's still something that's available, and so Nutanix was one of the first, really the only hyper-converged vendor to do a private cloud reference architecture or private cloud fast-track solution, with Windows Azure Pack. So something that you could build out on your own, and we have several customers doing that today to give that self-service to their users.
Yep. And so with the combination of this, you've got your cloud interface from Azure Pack, and you've got your cloud experience for the infrastructure from Nutanix. So it gives you both sides of it.
And so we took that another step. And so the reference architecture is great. You kind of give people a definition and understanding of how to do the install, how to set things up, what's supported, et cetera. But a lot of people want a more of a turnkey solution as a part of that. So this past year, we introduced the cloud platform system for Nutanix. So has anyone had any familiarity with CPS, cloud platform system from Microsoft? So this started with Dell. So they had an offering from Dell. The enterprise form of this really started at rack scale, so you'd buy a rack for a certain amount. And that really started at a very large scale, more so than a lot of companies wanted to start. So Microsoft opened up the program to Nutanix to allow you to really start at a much smaller scale as a form of CPS standard. So that's the same underlying software. So Azure Pack, System Center, Virtual Machine Manager, Operations Manager, really across the board. But instead of you installing it on your own, it actually becomes pre-configured from the factory. So we literally include Hyper-V. So we talked about that imaging process. In this case, we'd actually ship the nodes and the block with Hyper-V already installed. We'd ship with the virtual hard disks associated with SCOM and SCVMM, the Azure Pack Admin Portal, Azure Pack Tenant Portal, et cetera, on the box. You'd get it on site. You'd IP everything up and literally boot it up. And after 2 hours, you would have this completely installed and configured. You'd have VMM configured to consume the compute resources of the cluster. You'd be able to use the Azure Pack already up and running to literally start deploying VMs as a tenant from literally an hour and a half to 2 hours later.
Mm-hmm. Yeah, and even if you're not looking for a brand new solution that provides all this, anyone can benefit from the work that Microsoft and Nutanix have done together with this. For example, I was just recently talking to someone who was, already had SCVMM. I was like, well, you can still benefit from the CPS stuff by just installing Azure Pack on top of it. CPS just bundles it all together in a nice automated fashion.
Yeah, and a lot of people have asked us at the booth and throughout the conference, where are you going with Azure Stack as well? And if you've been in any of the Azure Stack sessions, Microsoft is starting with a very small ecosystem, based completely on Microsoft software. But you can see, based on the history that we've had through the reference architecture, through CPS standard, that as soon as when the program opens up, we're going to be right there and looking to support the Azure Stack as well. So let's talk about applications. So we talked about really being able to run any application on our platform. Again, we have examples of people running big data applications, examples of people using enterprise applications, and focusing on some of the Microsoft applications. The key, really, for keeping things on premises and maybe not moving things to the cloud, a lot of times is around performance and control. So really giving you the capability of running a high-scale SQL database workload, running Microsoft Exchange or SharePoint or Dynamics or whatever it happens to be, but really giving you the control, the performance, the scalability to do that on premises. A lot of times, especially with SQL workloads, SQL versions tend to be pretty sticky. So you might be, I talk to customers that still have SQL 2005 installed. SQL 2008 is very, very common. People are just starting to go to 2012, and obviously, if they can, 2014 or even 2016. So you have different requirements, maybe different licensing levels or different versions that may or may not have replication built in. So having a platform that can do some kind of data replication to give you business continuance or disaster recovery is important. And whether that's on-prem or even replicating to the cloud, that's something that we can offer as well. And like I said, taking the same benefits that you would get out of a traditional 3-tier infrastructure and really boiling it down to make it very easy to consume, fractional consumption, so your cost up front is cheaper, but also easier to use, so your OpEx is a lot lower as well, and really elevating the conversation to where you can focus on those applications. Chris, anything to add there?
Yeah, it's really all about, with business applications and Microsoft applications, I mean, what you care about is the application. That's what you're trying to deliver, that's what you want. The more time you can spend focusing on that and making that run the best, the better. And so Nutanix's goal is to make it so you don't have to worry about the infrastructure anymore.
Yeah, so how many people are running Exchange in their environment today? Handful? Now, are you also using Office 365? Show of hands? Yeah, so a lot of people are looking at a hybrid environment when it comes to Exchange. A lot of people will just simply move to Office 365. That's great. But some people want specific control, compliance, maybe it's archiving, maybe it's data sovereignty, maybe you're a bank or something, you're just not ready to move that data up to the cloud. Or you can determine which users do you want to move at a given time. So Office 365 is great. It's something that you can absolutely use, but having an on-prem solution is something that people want as well. In fact, I was talking with a customer in our booth. They wanted new functionality, so they're going to move to Exchange 2016, but at the same time, they also want to have the control on-prem, but then at the same time, they're also going to use Office 365 and move specific users as they need to. So really, the main benefit of using something like Nutanix on-prem is you, again, get that cloud-like agility, but at the same time, you have full control over that environment. Total cost of ownership is still extremely low. You get the densities that you need. Anything to add there? So really, all the benefits that we talked about, a lot of people are reticent to virtualize Exchange. They look at bare metal deployments. A lot of Microsoft recommendation is say, hey, just do bare metal, do direct attached storage. We feel we really give you the best of both worlds. So if you virtualize Exchange, you get the benefit of inherent HA within that virtualization layer. We like to deploy on an N+1 model, meaning that you'll have a core set of servers that are running your Exchange servers themselves, virtualized. But then if you were to lose a node, you'd actually have an HA process of moving that VM over to that other node. You're not having to, say, reseed data within that database availability group or anything along those lines. I mean, has anyone that have done the Exchange deployment, are you fully relying on direct attached storage and availability groups for HA? Yeah, so we have a handful of that. So one of the challenges with that is, hot spares. So how do you enable a hot spare if you lose a drive so you don't have to actually reseed a DAG copy or do a DAG failover as a part of the environment? So one of the benefits for us is because we're doing that data replication underneath the covers, we'll make it so if you do have a drive failure, like I said earlier, you would just simply rebuild to a smaller state, replace that drive, rebalance it back out. No DAG failover, no need to configure or set up hot spares. You're really not worrying about it. So that really means that you don't need as many DAG copies that you had previously. So a lot of environments, when they use availability groups, they'll have 3 copies or maybe even 4 copies of the data, because if you're not protecting it at the storage layer, you really need to have multiple copies at the server layer. But imagine eliminating the need to have as many, but then getting the same benefits of HA and high availability at the hypervisor layer and really at the virtual machine layer.
Yeah, and another great reason that Nutanix works really well for Exchange is that Microsoft recommends a scale-out deployment model for Exchange. Yeah, they recommend maximum of 92 I want to say 96 gigs of RAM and a certain level of processor. So you can't just make a massive server and have it run Exchange. So it makes sense to use an infrastructure that does the same, that scales out linearly, giving you that the flexibility. And then, as to the DAG point, is that you can actually reduce the number of Windows installations you need to make your environment that much simpler to do when you combine RRF with their DAGs.
Yeah, and on top of that, every DAG copy is really 100% overhead, if you will. So every copy is 100% of the data that you'd have within another database availability group. So having the data efficiency that we talked about within the platform, be able to compress that data, or even use something like erasure coding, which is if you're not familiar with the term erasure coding, it's a form of RAID 5 or RAID 6. But in our case, it's software defined. It's really not defined on hardware boundaries, but it gives you that parity-based data protection to actually reduce the amount of storage overhead associated with having an additional copy. So instead of a 100% or 200% overhead, if you have 3 copies, you're actually breaking that down to a much smaller ratio. So not only are you getting the data protection and not having to worry about hot spares and things like that, but you're actually getting higher efficiency than if you kept another DAG copy around.
Mm-hmm. You can use your volume license. We don't. We actually. That's one of the reasons we ship with KVM, because we don't sell any hypervisor licenses. So if you're using Hyper-V, you can use your volume licenses just the same.
Yeah. So the question was really around: do we include licenses with the appliance, or for the purposes of operating system, or anything along those lines? It's really what you have as a part of your enterprise agreement, or what you've already purchased. So we'll throw Hyper-V on there for you, and then you would use your existing licenses. Yep.
Yep.
And to that point, we talked about flexibility, right? You shouldn't care about the underlying hypervisor. Obviously, people focus on that based on comfort level and what they're familiar with and what they have as a part of their data center. But really, we have qualified Exchange across all 3 of the hypervisor variants that we offer. And we've gone through the Exchange Solution Review Program and have done an ESRP on Hyper-V as well as our hypervisor AHV. In addition, on AHV, we've gone through the Server Virtualization Validation Program, SVVP. So it's a way to qualify a third-party hypervisor. ESX does this to support Windows. We did it as well as a part of AHV to support Windows. So fully supported configurations, gone through ESRP validations, which I think is pretty cool to have an ESRP based on AHV. Yep. And like we talked about, an Exchange type configuration with database availability groups, really giving you the flexibility if you want to just have a couple DAG copies just for the purposes of HA. If it's local within a particular data center, that's great. Again, our storage fabric is going to give you that high availability and protection from a site perspective. But if you need more copies, whether you want to replicate to a disaster recovery site that could be some distance away, we give you that flexibility as well. But really, at the end of the day, it's full choice and full flexibility when it comes to the design that you have. But on top of it, having the efficiency with the way that we replicate data.
And to that, we call it out here, but I just wanted to emphasize it. So the ESRP we did, we got 30K mailboxes on 3 hosts. So 30K mailboxes on 6 RU, and that's it. So you can get some very dense things here, and you have full flexibility in how you want to protect the data and set it up.
Yeah, absolutely. And we talk about specific kinds of models. So we have some that are more storage dense, more compute dense. The reality is it depends on the number of users that you have in your environment for the kind of model that you would use. We like to talk about the ability to scale out, like Chris was saying, X number of gigabytes and X amount of CPU per Exchange virtual machine. And you can literally size these boxes to just run, maybe 1 or 2 Exchange virtual machines for the purposes of HA. So giving you the flexibility to have choice, but also at the same time, reduce the footprint that you would otherwise have within your data center. And we're literally taking environments that are 2, 3, 4 racks and reducing it down to half a rack, based on this kind of consolidation, consuming the storage local to the nodes, right-sizing the memory and CPU, saving you on power, cooling, and data center space. And we have specific appliances, if you will, which are great for Exchange. But like I said, the reality is the number of users that you can consolidate down is really dependent on your environment. So if you have 500 users, you could literally run them on a 2U appliance. If you have large-scale environments, like Chris said, we have customers doing 30,000, even 50,000 mailboxes. Obviously, that's going to take up more space. But as you grow, as you expand, just think you can add a node at a time. So if you're a large enterprise and you maybe purchase another company, those users come onto your environment. Something that you didn't foresee, you don't have to oversize and buy some huge, storage array to have the space available to consume those resources. You can really grow as you need to by adding a node at a time.
How does it work with the different nodes if you have like a newer model versus an older model? The newer model has so much storage, so much CPU, and the older model.
Yeah, so the question was, how does it work if you've got a newer model and an older model, and the newer model has more CPU, a better CPU or a different kind of CPU and storage? So from a CPU like compatibility metric or compatibility aspect, it's going to be, you'd enable the option in Hyper-V to enable CPU compatibility. So at that point, you can do live migration. If you've got different sizes of nodes, we have a process in the back end called Curator, which works to make sure that all of nodes have about the same percentage value of space. So you might have, if you've got one node that stores 40 terabytes and one node that stores 4 terabytes, and you're using 10% capacity, well, the 40 terabyte one will have 4 tears, and the 4 terabyte one will have 400 gig. We keep it balanced across.
And that's really a kind of a unique feature. So the idea of a heterogeneous cluster, not only from a CPU model or version perspective, if you have one Broadwell, one Haswell, and using processor compatibility or EVC, depending on your hypervisor, but also the idea that you could have different storage densities per node, and we refer to that as a heterogeneous cluster. So if you don't necessarily have to grow the environment based on the same memory and compute and storage at the same time. So for example, we have the concept of a storage-only node. So if you just want to grow the storage, you just need additional capacity. You don't need additional compute. You're not going to run virtual machines on that storage-only node. We give you that flexibility. Yeah. And to be able to do that, you have to have some level of balance, if you will, and that's the Curator process that we run, map-reduce jobs, to ensure that all the nodes are evenly distributing that data, whether they're operating as a compute node or even just a storage node.
You have just a storage node when you had the original slide where you said VM would go to where the storage was, where the write was?
Yeah. So you got to remember, so there's two parts of a VM storage, right? Is the hot data, the data that we're constantly accessing, and then the cold archive data. So for hot data, we keep that as close to the VM as possible in SSD at all times. By the time it's cold and we age it out of the hot tier down to the cold tier, it doesn't really matter where in the cluster that is, because the hard drives are so much slower than the network. So basically, if you say you have a storage-only node over here and you've got your VMs over here, if the VM starts reading data from the storage-only node, we'll move that data up into the hot tier on the node that the VM's running on. Then later on, if when stuff moves out of the hot tier, we'll rebalance and we'll move some other stuff over to the cold tier cluster. So, we also have all flash systems if you want just consistent performance across. And in that case, then it's just all flash. It's all SSD.
Yeah,
so.
and we operate based on data locality, but we're not required to. So at the end of the day, we have a tiering preference. So we prefer local SSD. Our next preference is remote SSD. Our next preference is local hard disk, and our next preference is remote hard disk. So we literally maintain metrics within the system where, because we tier vertically as well as horizontally, so we'll up tier and down tier as Chris was saying, but we actually maintain hard disk metrics, response times for the local node and all the remote nodes, whether it's storage only or something else that's running compute. So if we hit a certain threshold of reads on our local node, we'll actually query the remote nodes, see what their response times are, and if they're lower, we'll go ahead and utilize those remote nodes as well. So we talked about data locality and running the VM and keeping it local. That's great. We'll do that to the best of our ability. But if there's scenarios where it would actually improve performance to go remote by spinning up more HDDs, we'll do that as well. So some of that logic is tied to storage only, as well as the tiering algorithm that we talked about. That help?
Yeah, I mean, the real short answer is that for SSDs and above, that's when data locality matters. And when you're back into HDDs, then we get back into the reason we made storage arrays to begin with.
Yep, so like we talked about, scaling up, whether you have one DAG, two DAGs, whatever it happens to be. You can run your infrastructure services on these, really consolidating the roles, the Exchange roles, all the newer deployments of Exchange. They want you to consolidate, the CAS server and the other servers within Exchange onto a single role, running on the Exchange servers themselves. So it's a great design methodology, and it's something we absolutely support and cater for. Now, for databases, Exchange is a database, but obviously over the years, Exchange has gotten more and more efficient with respect to how it uses storage. Larger page sizes, larger memory amounts allowed per server. The way they've done the tables have changed. So the IOPS required, if anyone's run Exchange 2003, compared to what it is today, is night and day. I used to talk with customers back in the day who were running Exchange 2003 years ago, where they were even considering all flash back then when it was super expensive for Exchange 2003 because it was so busy. But Exchange has evolved to where you can really use commodity 7200 RPM drives to support it. But when it comes to your mission critical databases, whether that's SQL, could be Oracle, whatever it happens to be, those tend to be very I/O sensitive to response time, sensitive to throughput, and a lot of times for database workloads, you'll have a mix of them in an environment. It could be your primary database running an OLAP workload, OLTP for transaction processing, but invariably you're going to have test and development within that environment as well. So if you were using shared storage, having these different competing workloads all running against the same platform, and storage becomes a very, very primary driver of the way in which you're going to design the system. So similar to what we've been talking about, we add a lot of flexibility as a part of your database workload. So having hybrid systems, having SSD and HDD, really what we do is size those database servers to utilize their working set size within the SSD tier. So whether it's a hybrid system or even really an all-flash system, we'll give you that flexibility. A lot of the best practices as they pertain to SQL Server with Nutanix are based on virtualization. I know a lot of people are sensitive about virtualizing, their large database workloads. So we give a lot of prescription and guidance for how you would do that with respect to virtualization. One of the cool things that we also do is if you have non-virtualized database workloads, believe it or not, that's very, very common. Does anyone have physical servers running SQL that are not virtualized? Yep, a handful. It's super common out there. So one of the things that we did was, we talk about VMs and data locality and things of that nature, but we actually made it possible to consume the storage resources within our fabric externally. So if you have a bare metal server that requires additional space or additional storage that you don't want to virtualize yet, you can actually carve out storage and present it over iSCSI to those bare metal workloads. So again, you talk about an enterprise cloud platform. We want it to be more than just for virtualization necessarily if you have those kinds of requirements. So taking it, and this is something that we call block services. Really give you a scale-up option to be able to deploy SQL Server. Anything?
And then we also have data reduction techniques that we've talked about, compression, dedupe, and others. We don't make any claims about crazy numbers you'll get because at the end of the day it depends on what your workload is. But we have seen a ton of success with inline compression. It's saved people a lot of space, and in the end of the day, using inline compression gives you more hot tier space, which improves performance in general.
Yeah, and if you think about SQL, depending on your licensing level, depending on what version you're at, you may or may not be able to enable compression at the SQL layer, whether that's backup compression or even compression of the SQL database itself. So having that option at the storage level can be very beneficial. In fact, we even have customers that enabled SQL database compression on top of our compression and still saw a benefit. So SQL databases love compression. The way in which we do it in line is very performant, doesn't impact performance, and really gives you that benefit of a smaller storage footprint. Generally for databases, they're not going to dedupe well. I mean, the reality is each 8K page within a database is going to have a unique header. That unique header is going to essentially be different for any other pages within that same database. So enabling deduplication on a database generally doesn't give you much benefit. Where you do get benefit with database with respect to deduplication is if you had created a copy of that exact same database multiple times. So if you took the same database and made multiple copies, it'd be the same data structure as it was in the original. But if you're going to do that kind of copy, the better way to do it is with a snapshot. And with a snapshot, basically what you're doing is instead of doing dedupe, you're doing copy avoidance. So you're avoiding creating the copy to begin with. and essentially saving space in that sense, which is very, very good for your test and development environments. Along with those kinds of best practices around enabled compression, again, and just to give you an example with compression, generally for sizing, we'll recommend maybe a 1.5 to 2 to 1 space efficiency associated with compression. So very realistic number. It's what we see in production environments. It's what we see in our customers' environments. So, but I wouldn't believe claims from anyone saying 10 to 1, 20 to 1 data reduction. Likely, anyone giving you those kinds of numbers is talking about creating snapshots or clones of databases and then counting that as deduplication or space savings, where in reality, what that really is copy avoidance. You're avoiding making the copy, therefore, it is space efficient, but it's not truly deduplication. SQL Server was some of the best practices that have actually evolved. So if you look at some of the things that are occurring with SQL Server 2016, one of the best practices historically was to create multiple disks or multiple vDisks associated with TempDB, for example. Microsoft actually recommended creating a vDisk per CPU, really up to, and that's evolved into an additional disk or vDisk for TempDB up to 8, if you had 8 CPU or vCPU within your SQL instance. And with 2016, what they're doing is actually deploying TempDB in this fashion automatically. So if you install SQL Server 2016, it'll actually automatically detect the drives within the server, how many you have. It'll detect how many CPU you have within that box, and actually allocate TempDB automatically in this best practice form. So even as SQL has evolved, you start to get some of these best practices built in, whether you're virtualized or not. Now, one of the things people consider when they look at hyperconvergence is, well, it's great, I'm scaling out, but what if I need to scale up a virtual machine? So a lot of this design decision comes down to what are your administrative boundaries, and also, really how much do you need within a single database or really within a single instance of SQL Server? And that impacts licensing as well. Mm-hmm. So if you can scale up a given SQL instance with a given number of CPU, one of the great things about SQL licensing is it can be per virtual core. A lot of these servers that we have and use are very CPU dense. So you could have 24 cores per CPU or even more, mm-hmm. Very, very dense. So the question is, do I need to license all those cores, or do I just need to license what I use? And one of the great things about SQL is you can license just for that virtual machine and the cores that it's consuming. So when you start talking about scaling out or scaling up, you might actually scale up a virtual machine, get as much on there as you can based on maybe a faster CPU, and that'll help you save some of your licensing costs. If you scale out, it's great. It fits the platform very well. But really, either way, you're going to get the scalability with our platform.
Yeah, I mean, because if you take a look at this chart, the blue chart on the left is showing 1 VM, 2 VMs, 3 VMs, 4 VMs, each with 2 vCPUs. The chart on the right is showing 2 vCPUs, 4 vCPUs, and 8 vCPUs. So a single VM versus adding additional databases. And as you can see, there's actually very little difference between the performance that you get from scaling up versus scaling out, which gives you flexibility in how you want to actually do this deployment. We're running out of time.
Awesome. So we'll speed it up a little bit. But the idea is that you really have flexibility to choose the kind of allocation, if you will, with respect to CPU, the versions of SQL that you might run, whether it's standard edition or enterprise edition, whether you need failover clustering with shared storage, whether you want to run something like always on availability groups, you have a lot of flexibility at the end of the day. And like I mentioned about copy avoidance with SQL Server, instead of relying on deduplication, for example, for reducing copies, you can actually use something intelligent like snapshot mechanisms to take copies of your primary databases for the purpose of test and dev, hand those out to your developers. And one of the cool things about a scale-out platform like Nutanix is that as you run VMs on different nodes, they actually localize the data like we talked about and not impact each other as they run. So if your production environment's running on a particular node, you can actually have test dev in the same cluster, running on separate nodes, operating against really their localized data within that cluster, but at the same time benefiting from not having to create additional copies. So not only is it more performant, but also more efficient from a space utilization perspective.
This is just a quick example talking about the fact that we're software only means that we're continuously able to improve and continuously change how well the software works. As you can see here, in 4.1.2, they did a test that was cloning, doing 12 clones of a particular VM. Taking that same VM in 4.6, it took about a quarter of the time. And so this is, because we're software only, we're able to apply these updates on the fly without taking downtime and able to consistently get better without hardware upgrades.
And I think for this test, creating 12 VMs of a source within, I think it was like 5 minutes, and this actually broke it down to like a minute.
Yeah.
Just really dropping the deployment time, which was already very, very fast.
So, I mean, at the end of the day, the protection of your business critical apps and getting business continuity is one of the most important parts. Because if your application goes down, well, it doesn't really matter what it used to do. It's not helping you right now. And so Nutanix has a wide range of data protection that are able to protect you from anything from a single hardware failure up to a site failure. If you look down at the lower end of it, we have that self-healing where we take the system back into a redundant state after any failure. And then from there we go into a node redundancy, where if a node fails, we can automatically self-heal from that as well. And we can also, if one of our controller VMs goes down, we can automatically redirect the storage traffic to another host. So if our controller VM goes down, then the VMs on that host have no idea. They don't notice because HA kicks in. This allows us to do our non-disruptive upgrades because we're able to, one by one, turn on the HA route, restart, turn off the HA route, go to the next one, HA route, and so on. At the next level up, we have the ability to tune your redundancy and then use erasure coding to recover some of the space you lose with the higher redundancy levels. You can change the redundancy from RF2 to RF3 on a per container basis, so you're able to have some things that you care deeply about. Like, for example, if you have one cluster running both enterprise applications and running both SQL and Vue, for example, you might put RF3 on your SQL server because you care about that, but you might put RF2 on your Persona server because you don't really care about that information. So you're able to tune that. And there's another thing here that we think is really important is that we always have checksums enabled. We're always doing transparent consistency checks. Some HCI vendors don't do that, but we believe that data consistency is king. And so every test you see, every system you ever comes from us, any of that, always has the checksums turned on with no way to turn them off. From there, we start getting outside of just the infrastructure, and we have the VM-centric protection. We're able to take snapshots and do replication. And so here we have a chart that kind of shows the different levels and the different features we have to do, and their associated RPO and RTO. For those of you not familiar, RPO is how much data you're okay with losing, and RTO is how long it takes you to get back up. So yeah, you want to talk about that?
No, absolutely. And really, I mean, what you're looking at when you talk about Exchange and SQL and other applications is that you have options at the application level for doing replication, and you also have options within an infrastructure layer for doing that for doing replication. And you really have flexibility to mix and match and do both. But what a lot of people look to do is, regardless of the kind of app that they have, regardless of the licensing level that they have, which may or may not enable doing things at the application level, is having a consistent approach to doing that for their entire infrastructure. So whether it's a standalone instance of SQL that isn't using always-on availability groups, or a SharePoint instance, or Dynamics, or whatever it happens to be, having a consistent way of replicating that either across sites or even to the cloud. So. My mic is kind of going out. Do you want to?
Yeah. Yeah. So here in this the diagram, we show that you're able to send your snapshots in whatever way you want. You can choose. From one site, you can send it to multiple others. One site can be receiving from multiple others. You can send some one direction, some another direction. You can send it to 2 different sites. You've got basically unlimited options when it comes to that, including the ability to send backups and snapshots to the cloud. So you can back up to Azure and then recover from there. Finally, we have synchronous replication. So for that data that you absolutely cannot lose anything of, we can synchronously write to 2 different clusters at the same time. as long as they're within 5 milliseconds of each other. Because when we're doing sync rep, any latency between the two sites is immediately added to your write latency, because we've got to wait for the other site to acknowledge before we return. And so with this, you're able to, both sites see the same container or see the same set of data as if they were in the same cluster, and then you can choose which one's active. So if you have a failure, you can move your active container over to the other site and continue going as if nothing happened, because you didn't lose any data.
Yeah, and a lot of application-centric replication doesn't have synchronous, right? So for SQL, you can have synchronous commit with always-on availability groups, but again, you might have versions or licensing level that don't enable you to do that. So this gives you the capability at the storage layer to replicate between two different clusters synchronously, have that 0 RPO environment, regardless of the application that happens to be running. And like Chris mentioned, we also have Cloud Connect. So again, really we talked about early on about the application mobility fabric, giving the flexibility to move workloads between different hypervisors, but also be able to move and perform backup to the cloud. So whether it's AWS or even if you prefer Azure, giving you the capability of taking those virtual machines and containers in the future and taking snapshots and replicating those to your really cloud of choice. So yeah, that's been just a little bit about the different applications, the different way they work on Nutanix. Nutanix has gotten some very broad customer adoption across many different verticals. Many different companies are seeing the benefits of using this infrastructure for their environments, including the #1 companies in, well, I guess this is 16. The #1 companies in 16 different areas. Everyone from auto manufacturers to medical. Like Toyota.
Yeah, Toyota uses us. Best Buy uses us. We have a wide variety of industries, I guess is what I'm trying to say.
Yeah, I mean, a lot of people aren't familiar with hyperconvergence or not. Some people call it server SAN, and they're really trying to gain a comfort level with it. But the reality is, we've been in the market since 2011, really started in 2009. You probably heard Microsoft talk about Storage Spaces Direct at the conference. But hyperconvergence is really becoming a primary mode by which you can deploy infrastructure for your applications. And we've seen it grow across every vertical, across every kind of application. So it's something definitely to check out. And we have references in all of these industries, which is really important.
At the end of the day, we can present slides all day, but customer testimonial is the #1 thing. That's proof right there, whereas slides are just that.
So with that, any questions? Yes.
The app mobility fabric, did I understand it right that you're able to move VMs to different clouds based on different hypervisors?
Yeah.
So yeah, right now today, basically the vision for App Mobility Fabric is the ability to move between clouds, move between hypervisors, wherever you want. Today, the App Mobility Fabric only allows you to move between ESX and AHV, but we're looking at adding Hyper-V in there as well. So you're able to take a VM and move it from ESX to Hyper-V to AHV to Hyper-V, to wherever you want. And then the end goal is getting it so you can move it up to Azure or move it over to Google Cloud Services or wherever you want it. But right now today the actual product only does
AHV and ESXi?
Yeah.
Okay.
But the vision is to grow.
Yeah, so I guess you can look at it in two ways. So there's replicating between clusters with different hypervisors, and then replicating each one of those different hypervisors to the cloud. So any of those hypervisors can replicate to the cloud. So Hyper-V can replicate to Azure, AWS, as can AHV, as can ESXi. Today it's a backup target. So we're not spinning up the VMs within Azure. We're using it as a backup repository that you can retrieve back down to your on-premises. When it comes to replicating between hypervisors, to Chris's point, we support AHV to ESXi and the other way as well. Yep.
Yep.
You can technically replicate to any hypervisor as a backup target, but specifically to spinning up a virtual machine, it's between ESX and AHV for conversion. Yep.
Yep.
A good question. Anyone else? Well, thank you very much for your attention and your attendance. We have some, for those of you who stayed through, we have some Octopus cables here help you charge your various devices with a single plug. So you can come on up and grab some, and we really appreciate your time.
Thank you for coming.